In this chapter, we're going to be talking about Ampere's law. So the first thing we want to do is just go through a brief introduction to what it is. And I just want to go through it step by step. So we know that moving charges are essentially currents. These moving charges create magnetic fields. And these magnetic fields rotate around the source. So that's something that we already know. In the previous chapter, we talked about the Biot-Savart law. So the Biot-Savart law lets us find the magnetic field B for any current distribution. So what else can we try and figure out? So what the Biot-Savart law allows us to find the magnetic field for any current distribution, but we're missing a direct connection from between the magnetic field and its source. So Ampere's law is going to help us relate the magnetic field directly to its source. So how does it do this? First, let's go back to Gauss' law. So I'm just going to use Gauss' law as an analogy because the two laws are quite similar in the way they approach things. So while Gauss' law relates the electric field, E, to the enclosed charge, Ampere's law relates the magnetic field B to not an enclosed charge, but an enclosed current. And that enclosed current needs to be within a closed loop. So whereas we have Gaussian surfaces for Gauss' law, we're going to look at Amperian loops for Ampere's law. So what exactly is Ampere's law? I won't go into detail about what Ampere's law is until later on in this chapter, but we should probably start off with what it states. So Ampere's law states that if we calculate the line integral of the magnetic field around a closed loop, the result is going to be equal to the permeability of free space, basically a proportionality constant, times the enclosed current. So we write Ampere's law as the closed integral of the magnetic field dotted with dl, and that's equal to mu naught I enclosed. So we're going to take a look at that throughout the next few sections, and we're going to develop these ideas further to appreciate and apply Ampere's law.